Okay, it is part 5 of Laplace transforms dealing with multiplication by t power n. Now we come to this part particularly. If the Laplace transform of f of t is f of s, then Laplace transform of the same f of t where t is multiplied to that f of t, then the Laplace transform is taking the differentiation of this f of s multiplying with minus one time. If t square is multiplied, then we have to differentiate it two times, and minus 1 power 2 should be multiplied. That minus 1 power 2 is plus 1, that's why I have not written. In general, if f of t is multiplied with t power n, then this f of t, whatever Laplace transform is there, that same transform should be used, and we have to differentiate n times. So this rule is also remembered by saying differentiation of Laplace transform. Differentiation of Laplace transform. Now in conclusion, if we know the transform of f of t, then when f of t is multiplied with t power n, where n is 1, 2, 3, any integer positive, then this transform to be differentiated n times multiplied by minus 1 power n. Particular cases with t multiplied and t square multiplied are written here. Now you can take the screenshot of this. Okay, I'll take the problem now. Okay, let us take one example problem. Find L of, that is Laplace transform of t times of sine t. Now we cannot use first shifting theorem because there is no exponential in that. There are two functions, none of them is exponential. How do we do now? That is, we know that L of sine t is 1 by s square plus 1. Therefore, L of that same sine t, when multiplied with t, we have to differentiate this transform 1 by s square plus 1. If it is f of s, I am differentiating f of s one time because t is multiplied, and minus 1 power 1. On simplification, it is just minus. Now we need the derivative of this one. So what is the derivative of this one? It is like 1 by x. So minus 1 by x square. X square is nothing but s square plus 1 whole square. But this is again in not just x. So it is s square plus 1. So we need to multiply by chain rule the derivative for this one. So finally it is going to become 2s by s square plus 1 whole square. Okay, you can take the screenshot for this. Now for example, if we have another example, that is find L of t square into sine t, then sine t we know. If it is L of t square into sine t, then it will be minus 1 power 2 d square by ds square. So what we need to do now, this is already one time derivative. Again we need to differentiate this with respect to s. It is second derivative of this, and this one is the first derivative of this one. So again I need to differentiate it, and minus 1 power 2 is disappearing. So now I need the derivative of this one again. So minus 2 is a constant, I'll take it out. Again it is in the form of u by v now. D by ds of s by s square plus 1 whole square. Now how we need to do it? That is minus 2 times of, or else better I'll write it up for this one. That's equal to minus 2 is out. It's u by v rule. V square in the denominator, that is s square plus 1 whole square, again squared, that becomes power 4. So s square plus 1 whole square, that is v, into derivative of u, that is 1, minus s into derivative of this v. It is like x square, so 2x. So that will be 2 into s square plus 1. Again the derivative of s square plus 1, that is 2s. Now If you look at this, s square plus 1 is common in both of them. So I'll keep that minus 2 as it is. S square plus 1 I'll take common and I'll cancel with this. So what remains now? Only s square plus 1 3 times will be remaining. In the numerator this is gone one time. So s square plus 1 one more time is remaining. Minus. This s square plus 1 has gone out and cancelled. So 2s into 2s will be 4s square and the denominator is already written here. Okay. So on simplification it will be s square minus 4s square, that is minus 3s square, multiplied with minus 2, that will become plus 6s square, minus that plus 1 will get multiplied with minus 2, it is minus 2 by s square plus 1 whole cube. I hope you understood. Okay. So we can apply the multiplication concept t power n into f of t. When we know the transform for this and we want t power n times of this one, then it is minus 1 power n into whatever transform is there L of f of t, that should be differentiated n times. Okay, but if f of t is an exponential, that will become simple that way. Okay, for example, if you want to find what is L of t square into e power 3t, then do not go this way minus 1 power to d square by ds square of the Laplace transform for this one is 1 by s minus 3. It will be long, you can continue in that way. But the better point is that instead of going in this way, okay, we take up another way. That is so simple. When exponential is available in the product, then you just write what is the Laplace transform for this one. Okay, Laplace transform for the remaining function. I am using first shifting property or first shifting theorem. So whatever Laplace transform is there for t square, that is 2 by s cube, I need to change s with s minus 3. It is 2 by 2 factorial by s to the power of 2 plus 1. Okay, fine. So 2 by s minus 3 whole cube. I hope you understood. If you want to continue in that way, you can continue and confirm that it will be one and the same. But it is not appreciable. Don't go by this way. Okay, this is all about multiplication with t. Now you need to remember this, that when we know the transform for this, that transform will be differentiated n times if t power n is multiplied, where n is any positive integer 1, 2, 3, 4, so on, and minus 1 power n to be multiplied with that. Now you can make a guess. If I divide with t power n, or as a particular case, if I divide with the t instead of differentiation, it will be integration. That we'll see in the next part. Okay, thank you.